Before going further on with the more practical aspects of this work, we should focus for a moment on the main actors of the project. First of them all is Arduino, an open-source electronics platform based on an easy-to-use hardware and a software. Over the years, Arduino has been the brain of thousands of projects, from everyday objects to complex scientific instruments. The second required component for the work is the sensor itself. The sensor used in this case is an ultrasonic one. Ultrasonic sensors, in fact, are electronic devices that measure the distance of a target object by emitting ultrasonic sound waves. The reflected sound, later on, is converted into an electrical signal.
The next essential element used for our project is Bluetooth, a standard for the short-range wireless interconnection of mobile phones, computers, and other devices. So, by using an HC01 Bluetooth module on the Arduino board and a USB Bluetooth dongle attached to our PC, we were able to obtain a wireless communication between the two. The last but not least element needed for our project is ROS, an open-source robotic middleware suite that, by means of a publisher and a listener node, allows the communication between our PC and the robot through Bluetooth.
In this part of the video we can see the global working principle of our project. And so we can see that when we switching on the robot and after launching the ROS node on the terminal, we can see that the sensor starts to read the measure that appear on the terminal. When the distance became less than a threshold, we can see that the sensor stops to plot the distance on the terminal, and we can see from the wheel of the robot that the robot itself starts a series of maneuvers which allows to avoid the obstacle. During this operation, we can see that on the terminal the sensor doesn't plot any distance. While when these operations are completed, a new cycle starts, and so the sensor plot again the distance from the new obstacle.
Now we analyze the code implemented for Arduino. In the first part, we define all the variables related with the pins, such as the echo and trigger for the sensor, various other pins for the motor, and the parameter utilized for the motion of the robot, like the length and the width of the obstacle. Then there is the setup serial, where we simply set up the communication between the terminal and the robot. Moving on, the next block is the update ultrasonic, where we generate the trigger pulse, acquire the echo from the sensor, and then find the distance using a simple equation. After repeating this cycle 4 times, we compute the average. With the next line, we create the string with all the information that we need to be communicated with the terminal. Finally, we send the data with the Bluetooth and return the distance that will be needed for the motion.
In this block of code, we have the definition of the movement of the robot, which basically follows this scheme. The robot goes forward until an obstacle is detected at a distance lower than 20 cm. Here the code enters in the first if, and since it is supposed that no obstacle is posed on the left, the robot starts to move in that direction. After a certain time, it stops and goes straight forward. Then it is supposed to go right of the same distance previously made in the other direction in order to get back to the starting trajectory. After this part of code, there are some declaration of function needed for the motion of the robot, such as go left, go right, stop, and so on. Here are also declared the direction of the single wheel and their relative Arduino pin assignment. In the last part of code, we have the read from serial function, which basically reads the distance value from the ROS terminal, and the update all function, that is the main function and it is essential to make the car move. In this last clip, we can see the car approaching the obstacle and then trying to avoid it. We can also notice that, due to the faster rotation of the right wheel, the car tends to not follow the theoretical trajectory and tends to turn left